Hello everyone. We are the group 1 and we will be presenting our lab experiment number 7, which is about introduction to waveguides and microwave link investigations using horn antenna. So our group members are Cortez Dan, GUZMAN Aaron Jimwet, Alden Evangelista, ROQUE Don Warlon, and VALENTON Cesar. So waveguides. Waveguides are devices in which they carry signals from one point to another. Microwaves propagate signals through this type of device. This device is a hollow metal tube of a uniform cross-section, wherein the waves travel through the center by consecutive reflections inside the tube. A waveguide is similar to that of a transmission line, but the difference is that a waveguide lacks a conductor in the middle. The main characteristics of a waveguide include distributed capacitance along the wall in its hollow center. The tube wall produces dispersed inductance, and that they are usually heavy or big and costly. So the advantages of utilizing waveguides are efficient manufacturing. It can push through against high power applications. There is less loss of power, and there is only little attenuation compared to coaxial cables. There are various types of waveguides, such as the curricular waveguide, rectangular waveguide, elliptical waveguide, single ridge waveguide, and double ridge waveguide. The main difference between a transmission line and a waveguide is that the waveguide can handle transverse electric and transverse magnetic waves because of its utilization of one conductor in its structure. On the other hand, the transmission line utilizes two conductors in which it could handle the transverse along electromagnetic wave. So, fundamentals and basic principles of horn antenna. The horn antenna is mainly utilized in the shape of horn. It is mainly utilized in microwave frequencies. This antenna is basically like a waveguide but molded out in the shape of a horn, leading to more opportunities or applications for the utilization of waveguides. Its distinct shape allows it to guide to or direct radio waves through a beam. These are widely used as feed antennas, wherein its purpose would be measuring the gain of various antennas. The way that this type of antenna works is the same with the waveguide horn that is used for guiding the sound waves on the musical instruments of windpipes. Their shape allows for moderate passage structure to be able to match the impedance of a tube to the impedance of free space. When that happens, the tube is emitted into the space with efficiency. The waveguide is not in the shape of horn. There would be an immediate change in the impedance of the aperture of the antenna. This is due to the end of the conductive walls of the tube not being able to guide the wave or signal smoothly. The ultimately leads to standing wave in the waveguide, which is waste of energy. So for gain, directivity, aperture, range, distance, measurement of horn antenna. Since the horn antenna lacks resonant elements, which means that it can operate in a higher bandwidth or higher range of frequencies. The gain of the horn antennas is usually known to range up to 10 to 20 dBi and 25 dBi at maximum. The aperture of the horn antenna tends to be wide so that it could project the waves through a narrow beam. The aperture depends on the type of horn antenna since these are various types. The aperture efficiency of the horn antenna ranges from 0.4 to 0.8 in a practical sense. This increases when the length of the horn increases. Since horns have slightly losses, the directivity of the horn is almost equivalent to the gain. So, for the performance of horn antenna varies with the specific type that is used. Generally, Horn antennas are used in UHF and microwave frequencies which are higher than 300 MHz. The input impedance moderately transitions at a wide frequency range, which is usually 10:1 or 20:1 ratio of usable bandwidth. For instance, operating at frequency from 10 GHz to 29 GHz.